Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to the chapter that is Polymerization, that is for class 12 CBSE syllabus. Now it is part 2 where I will explain types of polymerization. Then question is, what is polymer? Poly means many. Poly means many and mer means unit. That means here you can see polymer, poly means many by Greek, and mono here, mer means unit. The unit is whether it is that means mer, M-E-R, mer, unit. Then how you can explain? See here, if it is monomer, what is that one? If it is monomer, mono means one, mer means unit. If it is one unit, then it is called monomer. If so many monomers are joined repeatedly and with structural unit on a large scale, and that is called polymer. That means small unit is called monomer and long chain, that is called polymer. Are you clear what is polymer? Polymer means many small units are joined repeatedly to form a long chain, and that is called polymer. And the phenomenon, the process, how we are getting polymers, that is called polymerization. Is it clear? Polymerization means, suppose example, in your daily life you take one single rose flower. You see one single rose flower, you can say it is monomer, single unit. But when you say so many rose flowers are joined repeatedly and gives what will give? A garland. Rose flower garland. This garland is called polymers and the process is called polymerization. And here, and that one single flower, rose flower, is called monomer. I hope it is clear how you are using in a daily life and what is polymer and polymerization. Next here we will see, if you are not subscribed my channel, please subscribe. BL Das Short and Sweet in Chemistry. Then come to classification of polymers. Classification. That means how the polymers are obtained that produce according to the nature and behavior of the process. That is why it is known as classification of polymers. Classification based on so many types of classifications are there. And first you see, that is classification based on source. That is what is meant based on source. Source, what are the type of source? That means here you can say, based on source. What is source? How we will get? That means man-made polymer, that is called synthetic, and half man and half that is from nature, semi-synthetic. But if you are getting from the totally from nature, that is called natural polymers. Are you clear? What is natural polymer? Found in nature. What is nature that will give? The nature gives plant and animals, where you will get that type of polymers that is called natural polymers. You know protein, starch, protein, that is you are taking every day in different way. Starch and cellulose. Starch and cellulose, these are the part of the mainly what? From the animal. Nucleic acid, that is available in our body, and etc. Protein, that is also one type of the things which is available, the polymer which is available in plant and animal, also plant product and animal product, and that is called natural polymer. Natural polymers are not so available in highly. That means you can't get so many polymers, much more polymers from nature. That is why the men already tried to how to get man-made polymers or semi-synthetic polymer. Semi-synthetic polymers mean what? Semi mean half Synthetic means man-made. That means you will get from natural polymer and from by the different chemicals. That natural polymer you take and modified by such chemicals so that you will get more polymers. Natural polymer you will take and it will be modified by the chemicals. Then only you will get a synthetic polymer. Semi-synthetic polymer. Now you can know that what is cellulose acetate. You can heard this word, cellulose acetate rayon. That means in commercially available, that is called rayon. For example, cellulose on acetylation with acetic anhydride in sulfuric acid, and that unit that polymer is called cellulose acetate. So cellulose acetate, if you see, that is only often from chemicals, often from monomer. Then what is the monomer here? Here you can take that cellulose that is from plant and acetate that is from acetic acid and sulfuric acid also are taking. Here acetylation also takes place. That means acetic anhydride is also added in presence of sulfuric acid. This is called cellulose acetate, and the commercial name is rayon, which is very, very important in our cotton, that means cloth industry. Then gone cotton is cellulose nitrate. It is called gone cotton and looks like our cotton, and so generally it is used for different type of cloth materials, and also different type explosive materials. So this is called cellulose nitrate. Then come to synthetic polymer. What is mean synthetic? Totally man-made, totally prepared in the lab by the help of human being, by the help of scientists. Polymers which prepare in the lab called synthetic polymer. Is it totally clear? Semi-synthetic, half man-made, half from chemical, and that is semi-synthetic, clear, and natural polymer, that is from nature, plant, animals. Synthetic, that often from by the man-made in lab. For example, polythene. These are generally used in our daily life. In daily life, it is used polythene, PVC, bakelite, nylon 6, etc. So many polymers there. Oh, you will read it now after this. So these are only often in lab. That is very easy to prepare, and also the cost is not so high in compared to natural polymer. That is why it is used in our daily life and different type of industry. Then come to here classifications. Number 1, classification based on natural source, and nowadays based on structure. How can you know that the structure, and depending on the structure the names are there based on linear structure. What is meant by linear? Linear, here you can see here, that is mean here you should know linear. The spelling is not correct here. Then see what is this, L-I-N-E-A-R, linear structure. So what is this? Linear structure. Linear mean what? Simply long chain structure. Simply long chain structure having high density and high melting point and high tensile strength. What is meant by high melting point? That means if you heat, that means it will not easily melt and requires a high temperature. High density, that means heaviness, and high tensile strength. Tensile strength means it can take the weight of any heavy weight, it can bear. Tensile strength. Example, see here, polythene, you know, polyvinyl chloride are high tensile strength. polythene, what are using in our daily life. So many types of polythene, weak polythene and highly costly also polythene that is very, very strong. These are the based on linear structure. And now simply see, this is the linear structure, simply straight line. Then come to here, branch chain polymer. Linear mean straight chain and branch mean having some branch. Long chain polymers with side chain or branch chain. What do you mean side chain or branch chain? Now see, in linear structure, it is only simply long chain. But when you see that is our branch chain, so surely there should be some side chain. There should be some side chain. Then what is that one? Branch or side chain, or you can say branch chain. So it is side chain or you can say branch chain. And next we will see how it is formed, having high low melting point. Since it is branch, that is why it can melt easily. The bond broken easily. Linear polymer. What is the value of the melting point? That is high in linear and melting point low in compared to linear structure. Irregularly packed, that means it is not regularly packing, and low tensile strength, that is why it has low tensile strength. So here you can see, if it is low tensile strength, what happens? It is not so strong in compared to our linear polymer. And so that is why examples, I told weak polythene and strong polythene. Some polythenes which are very, very weak, that is surely branch chain polymer, and glycogen and starch, they are very low melting point and they are very irregularly packed. See here, this is the branch chain. You can see this is the branch here, some branch are there, and side chain are there. That is why this is called branch and or chain polymer. And next come to cross-linked or network polymer. What is it? Cross-linked. That means here it should be crossed. And network means closely packed. It is closely packed. Monomer cross-linked to form three-dimensional network. I told network polymer, that means it is so much netted that here it gives a one three-dimensional structure, and they are more hard. They are more hard, rigid and brittle also, because it is highly packed. That is why it is very much brittle nature, formed from bifunctional and trifunctional monomers. Here only bifunctional. What is mean bifunctional and trifunctional monomers? That means monomers which having two functional group or three functional group, just like acid group, amide group. If they are present, then what happens? They are called bifunctional or trifunctional monomers. If they join, they give three-dimensional structure. And it is what are the examples and what is the structure of polymers, cross-linked polymers? See, this is the called cross-link. Here it is crossing. Here it is crossing, that is why cross-link polymer, and they only contain covalent bond which is very strong. Example, bakelite. What is bakelite? All the things will clear when you will come to, where you will come? That means you will come to preparation of different type of polymer. Now here it is bakelite structure, melamine structure. These are the cross-link, and melamine and bakelite you will read in the preparation part. So now remember bakelite and melamine, these are the important, that is cross-link polymer. Then come to this is finesse. First is natural, so then is that branch chain structure, and that last, that is not last, that is point classification based on molecular force. What is mean molecular force? Molecular force means intermolecular force, maybe hydrogen bond, maybe van der Waals force. So many types are there, but here only responsible the intermolecular force, that is van der Waals force and hydrogen bonding. Van der Waals force is very very weak force, but hydrogen bond is very strong force, so strong attraction. The example elastomer of fibers, thermoplastic, thermosetting. Then we will know what is my elastomer, fiber, thermoplastic, thermosetting. Thermo mean heat. So thermoplastic mean on heating it will changes, and thermosetting mean it will set. And elastomer mean that having elastic nature. Fiber mean it having different type of fabric structure. So you can see now what is the meaning of elastomers. Elastomers mean, here you can see elastomers, I told before, elastomer mean elastic nature, rubber like solid. What is that one? Rubber like solid with elastic property. You know what is mean elastic? When you stretch, you are giving stress, that will by small stress it will stretch and again regain original shape by removing stress. Just like rubber, you can see one rubber. If you stretch, give stress, it will stretch. If you remove the stress, it will come to original shape. This is rubber-like structure, that is called elastic property. What is this one? Elastic property. Example, these are all the type of rubber, Buna N, Buna S, neoprene. But here only remember the name, where we will see that preparation, how to make these are the synthetic polymer, how to make these synthetic polymers in the preparation we will see. Then come to fiber. What is fiber? Fiber means these are the thread like solid, high tensile strength and high modules, strong intermolecular force. The rubber where there is not so high strong force, but here in fiber the strong intermolecular force like hydrogen bonding or dipole interaction. What is that one? Hydrogen bonding. You know what is hydrogen bonding, and here this is dipole interaction. These are all the things you can know from 11th class chapter, that is chemical bonding. So close packing, because this is very in strong force, that is hydrogen bonding. That is why here it is crystalline structure, because if close packing, that should be crystalline structure. Example, polyester. You know, you heard the name polyester. What is polyester? Terlin, terracotta, Decron, all the names are there. All the names are you listen, you heard from the different type of source. You know what, then I am wearing terracotta dress, Terlin dress, Decron dress, like this. All are called polyester. And similarly here, polyamide. From this you can know, this is polyamide. Poly mean many, amide mean amide structure. So example, nylon. Polyacrylonitrile. What is nylon? Later I will say, but generally in commercially one should know nylon rope. You are saying bring one nylon rope, nylon material. That means it is very important in our commercial daily life. Polyacrylonitrile. That is also one type of synthetic polymer, where Orlon, acrylon, where the old dress are different, and nowadays no old dress is coming from natural source because it is too costly. It is also not available in market so much. That is why here you can use Orlon and acrylon, different type of different type polymers. In polyamide, the intermolecular forces in polyamide, hydrogen bonding are used. In polyester, polyacrylonitrile, intermolecular forces are used. sorry. So these are dipole-dipole interaction. That means polyester, this force is existing. Polyamide, this force, hydrogen bonding exists. Then come to thermoplastic polymer. What is thermoplastic polymer? They are linear, light branch, not so heavily branched long chain. Light branch, small substituent. On heating, it is softened. Very important. Thermoplastic, on heating, it is softened. Again, it is cooling, it is hard. Then you can give different shape, different modules. According to your choice, on heating you make soft and cooling you make different shapes according to your choice. But because on cooling, it will come to hard. So you can give different shape. Then come to the other examples. Chains are held by weak van der Waals force. Here the force of attraction, that is van der Waals force, which is very, very weak, and that is existing between our elastomer and fiber. This is existing between elastomer and fiber. Examples: polythene, polystyrene, and polyvinyl chloride, and Teflon. That is polythene, polystyrene, polyvinyl chloride, and so these are used in daily life. So what about polythene, polystyrene, like this? They on heating become soft, on cooling become hard and having different shape. Thermosetting polymer, cross-linked or heavily branched. Now see, thermoplastic polymer where light branch pair present or linear structure present, and here thermosetting, this is heavily branched or cross-linked present. So on heating it is hard. When you will heat, immediately hard. You see comb is one, when you heat immediately becomes hard. Infusible, insoluble mass. When you heat any plastic just like comb, it becomes insoluble mass and not reused. Because if it becomes hard on heating, how can you make different product? Because it is not reused. That is why it is not reused, because it becomes hard on heating, become infusible, insoluble. And that is permanent hardness. It is not a temporary hardness. It is permanent hardness. So these are the types of classification of polymers. And thanks for watching my video. And thanks to all again. In this video, I have explained different type of classification, and in coming video, I will explain addition and condensation polymer. Addition and condensation, that is very important. And here, what is addition? What is condensation? What are the other names of addition and condensation? You will see in coming video, which is very, very important in polymer chapter. Hope you will subscribe my channel BL Das Short and Sweet in Chemistry, so that I will produce more videos for you.